Hey everybody, in this video we are going to get into example 2. Example 2 requires the use of the Pythagorean theorem for right triangles. Recall that the legs of a right triangle form a right angle and the hypotenuse is the side opposite the right angle. So you could look right here for a drawing. The legs are the ones that make the L for leg, and the hypotenuse is opposite or across from the right angle. All right, it's never touching the right angle. Oops, not eraser. All right, and the Pythagorean theorem is leg squared plus leg squared is hypotenuse squared. Please keep in mind you cannot take the square root of a sum or a difference. You must combine like terms first. Okay. There might be extraneous solutions in this case as well. Don't forget, whenever you take a square root, when you do Pythagorean theorem, if you take the square root yourself, it's really plus minus. So if I did the square root of 25 to find the length of a side, I only want the positive 5 because you can now have a negative 5 as a side length. When you get into more trigonometry and you're drawing angles in standard position and you're drawing triangles on the xy plane in that regard, you can have negative meaning left or down, but you don't have negative length, okay? So let's get into example 2. A piece of property has the shape of a right triangle. So what do we do to kick off everything? Of course, we draw a picture. Okay, there we go. The longer leg, I'll make that right here, okay? That's going to be the longer leg, is equals 20 meters longer than twice the length of the shorter leg. Oh boy. So where's our let statement? Let x be the shorter leg. So we keep track of what it is. So if that's x, the longer leg is 20 longer than twice the length of the shorter leg. So there you go. 2x plus 20. Let's fit it a little better, sorry. Okay. Now, as soon as I'm already seeing this, and I know I have to do Pythagorean theorem with a sum, you want to make sure that when you square 2x plus 20, that you know it's so nice you write it twice and you FOIL and you don't just square the 2x and the 20, correct? Correct. So we got that. The hypotenuse is equals 10 meters longer than the length of the longer leg. So it's 10 more than this. So that means this is 2x plus 20 plus 10, or 2x plus 30. So the hypotenuse is 2x plus 30, and it looks like everything's in meters. Okay, so from here, keep reading. Find the lengths of the sides of the triangular lot. So we have all these clues, and we got to find the lengths of the sides of the triangular lot. So I'm looking for all three sides. So find all three sides. And I'll even set it up. So I'll have shorter leg, longer leg, and hypotenuse. Now, the benefit of setting it up is that you know at the end that you found everything you needed to find and you're good to go. So that's what I need to find to be done with the problem. So we can, if you look, we only have one variable. I have x here, I have x here, and I have over there another x expression. In order to solve for one unknown, I just need one equation. If I had two unknowns, I would need two equations and so on. So I really could have written this with you know, X for one side, Y for this, X for this, Z for this, whatever. And I could have written all these separate little baby equations on the side that I basically subbed in right away. And I would have more unknowns and more equations, but we kind of set this up. Okay. So I'm going to use Pythagorean theorem. Why? Because I know that this is a right triangle. And if it's a right triangle, then the sides would satisfy the Pythagorean theorem. So I'm going to scroll a bit, give myself some space, and do the work down over here. So leg squared, x squared, plus other leg squared, 2x plus 20 squared equals hypotenuse squared, 2x plus 30 squared. All right, so I'm set up and ready to go. The x squared, well, that doesn't really do much of anything now, does it, right? It's just really x squared. If I FOIL the next one, I'm going to get 4x squared. Outer is 40x, inner is 40x, so plus 80x plus 20 times 20 is 400 equals 4x squared again. Outer would be, if I wrote it twice, right, 60, inner 60x, so I get in the middle 120x, and 30 times 30, last times last, is 900. Okay, so that's where we are right now. Now, like we've been doing, to solve any polynomial equation, we need to get that equation equal to 0 first. So in order to get it equal to 0, I'm going to do a couple things at once. I'm going to combine like terms, and I'm going to subtract 4x squared, 120x, and 900 from the right. And I'm going to put everything in descending exponential order, meaning standard form, meaning ax squared plus bx plus c, right? So the biggest power is first, and my powers get smaller as I move to the right. All right, so what will I get? Let's see. If I subtract 4x squared over, this and this are going to be gone, right? So that's going to go away. So I will have x squared. Now here I have 80x, and I'm going to subtract 120x. So that means I will have minus 40x. And then here I have 400. I'm going to subtract over the 900. That means I have minus 500 equals 0. So that's not so bad now, is it? Now, this one's actually really easy to factor. What multiplies AC? What multiplies to give you negative 500, but adds or subtracts to give you negative 40? I could kind of see it right away. Can you guys see 10 and 50, right? And that would mean I need negative 10, a negative 50 and positive 10. And again, I'm going to jump right to my factored form. If you need to do it out longer, please don't try to be a hero. So I will have plus 10 and minus 50. Then to finish with the zero product property, we're going to set each factor equal to 0. So I'm going to get x plus 10 equals 0, so x equals negative 10, which is obviously extraneous. That's our extra solution that does not fit the circumstances. So we can say goodbye to that. And here we will get x minus 50 equals 0, so x equals 50. And we said everything was measured in meters. So now this answer is going to set me up to find all three sides, right? So what did we say? Let x be the shorter leg. All right, so the shorter leg was x. And we said that that was going to be, oops, I don't want a highlighter, I want this, 50 meters. Now I want the next side, let's say the longer leg, right? And that's going to be 2 times whatever x was. X was 50, so 2 times 50 is 100, plus 20, so 120 meters. We wanted to show the work. Maybe we go here. Longer leg equals, right? 2 times 50 plus 20, 100 plus 20, 120. So I'm just showing my work. And then I'll call that guy. That's not the best curly bracket, is it? H. And then the hypotenuse, 2 times x plus 30. Or it's 10 more. I mean, I know it's going to be 130, right? 10 more than the last one equals, actually, yeah, let's just do that. H equals, we said L plus 10. So, not 50. 120 plus 10. So, 130 meters. There you go. And that one we crossed out was extraneous. And that right there, or that right there, is like the little formula we used to find our hypotenuse. And those are the dimensions of the plot of land. Okay, so 50 meters for the short leg, then 120 meters for the long leg, and 130 meters for the hypotenuse. So now I mentioned to you guys that there are Pythagorean triples. One of those Pythagorean triples is 5, 12, 13. So this is an example of the 5, 12, 13 Pythagorean triple, but it's all being multiplied by 10, scaled up by a scale factor of 10. So it gave us 50, 120, and 130, right? So that makes sense for us as well. So there you have it. That is the end of this example. I hope you're able to redo one like that on your own. I hope that you found this helpful. I hope you can do an example like this later by yourself, so give a thumbs up. If not, thumbs down, questions or comments, please, by all means, check the description box for the other videos sort of organized in a list, or you could check the playlist if you like to look for them that way. Hope you find whatever it is you're looking for. That's it for now. Adios. Bye.